For centuries, we've pumped greenhouse gases into the atmosphere. Now, the climate is changing and changing fast. What do we do? Stick around and we'll look at options. Hi, I'm Tom Olivier for ASAP. Thanks for watching. In this video and the next, we'll look at steps we can take to contain and adapt to climate change. Let's be clear about something. It's too late to completely stop human-caused climate change. Since the start of the industrial era, we've released about 2,200 gigatons of carbon dioxide, or CO2, into the atmosphere, along with other greenhouse gases. Those emissions have already raised the Earth's temperature about 1 degree centigrade. But actions we take in the next 2 decades can have great effects on the severity of climate change during the rest of this century. The Intergovernmental Panel on Climate Change, or IPCC, was created by the United Nations to analyze and report on climate change. This graph is from a 2014 IPCC report. The red line illustrates temperature projections over the remainder of this century if we do little to limit future greenhouse gas emissions. The pink area indicates uncertainties in these projections. As we can see, the value of the red line exceeds 4 degrees by 2100. In contrast, the blue line shows projected temperatures in a scenario where we rapidly implement aggressive steps to reduce atmospheric greenhouse gases. The lighter blue area indicates uncertainties with these projections. Blue line values mostly are near the 1 degree value. Here are some things expected to occur or increase with increasing temperatures: droughts, sea level rises, big wildfires, bigger storms, biodiversity range shifts and losses, ocean current shifts, crop failures, new disease patterns, wars over resources, mass migrations of climate refugees. Broadly, as we move along the increased temperature axis, climate change impacts are expected to increase in kind and in severity. So, can we contain global temperature increases to a value compatible with survival of the biosphere and human societies, largely as we know them? If so, what is that critical value? In 2015, representatives of many nations met in Paris to discuss a global effort to contain climate change. At the meeting, nations agreed to work to limit the global temperature increase to below 2 degrees centigrade, with strong efforts to contain the increase to 1.5 degrees. In 2018, the IPCC released a report on how the world would look with the 1.5 and 2 degree temperature increases and the actions required to reach those goals. The good news is that greenhouse gases already in the atmosphere are unlikely to cause a 1.5 degree temperature increase. The bad news is that if current trends continue, we will have emitted enough greenhouse gases to reach a 1.5 degree temperature increase sometime between roughly 2030 and 2050. The IPCC report indicated that further disruptions to the biosphere and human societies will appear with a 1.5 degree increase, and yet more disruptions will arrive at 2 degrees. Crucially, the report indicated that we must reduce new CO2 emissions and simultaneously implement strong measures to draw down greenhouse gases from the atmosphere. How do we do all of that? Some measures will please tree huggers. We can restore forests and other ecosystems that have been destroyed by human activities. Photosynthesis in the systems will remove atmospheric carbon. We also can promote agricultural systems that elevate soil organic matter. Silvopasture, rotational grazing, and permaculture all are possibilities. But recent papers in Science Advances and proceedings of the National Academy of Sciences suggest that so-called natural methods can accomplish less than half of needed atmospheric greenhouse gas removals. That leaves us turning to man-made techniques and systems that will draw down CO2 and other greenhouse gases from the atmosphere. Some proposed systems capture CO2 at point emission sources or from the air and then incorporate the CO2 into useful products or store it in geological formations. Other proposals call for fertilizing the oceans to promote algal blooms that are to capture carbon. We even have proposals to scatter particles in the upper atmosphere to block sunlight and thus help cool the earth. What could go wrong? Given the risks and uncertainties attached to some of these proposals, don't be surprised if nuclear power gets strong reconsideration. Another method of strongly reducing future atmospheric greenhouse gases exists, one using proven low-cost technologies. Given that this is an ASAP video, you probably can guess that I'm talking about, drumroll, reducing future greenhouse gas emissions by reducing the rate of growth of our population, reducing the growth rate through voluntary family planning. Put another way, in our efforts to protect the biosphere, we must include containment of human population growth. It's simple. Beginning with the first breath of air that we exhale after being born, each of us, as we live our lives, releases greenhouse gases into the atmosphere. The UN projects human population growth to continue to the end of this century. If we can reduce our population below projected levels, we can reduce future additions of greenhouse gases to the atmosphere and reduce removals of greenhouse gases from the atmosphere needed to contain future temperature increases. Now we can get a lot more technical. In a 2012 report in the Lancet on connections between demographic changes and atmospheric CO2, Brian O'Neill and colleagues state, empirical analyses of historical trends tend to show that CO2 emissions from energy use respond almost proportionately to changes in population size, and their results imply that policies that slow population growth would probably also have climate-related benefits. This graph from the Lancet report shows variations in CO2 emissions associated with low, medium, and high population growth scenarios. These scenarios are based on earlier UN population projections. Emission assumptions are based on the earlier IPCC B2 generally low emission scenario. Plainly, the higher the growth rate, the higher the emissions. In a 2010 paper in Proceedings of the National Academy of Sciences, O'Neill and colleagues report, we show that slowing population growth could provide 16 to 29% of emissions reductions suggested to be necessary by 2050 to avoid dangerous climate change. Clearly, containing human population growth will be of enormous value in efforts to reduce dangerous global warming. Yet in a 2018 article in Science magazine, John Bongaarts and Brian O'Neill pointed out, the Intergovernmental Panel on Climate Change is largely silent about the potential for population policy to reduce risks from global warming. In an era when we are seriously considering spewing particles into the atmosphere to block the rays of the sun to limit climate change, it's madness that plain old voluntary family planning isn't already a central strategy. That's about it for this video. In the next video, we'll look at ways to adapt to climate changes that already are baked into our future. We hope you'll watch that video too. ASAP appreciates you visiting our YouTube channel. We encourage you to visit our website, asapvirginia.org, and our Facebook page. Thanks again for watching.